Hello, my name is Greg Crinklaw, and we're going to set up an observing location in SkyTools 4. I'm going to go up here to the Setup menu, choose Locations, come down to New, click New. I'm not going to select from the list here. I'm going to go over to Manual GPS Entry. I'm going to type in the name of my location, which is Mesa Redonda Observatory. Its longitude is 106 degrees west, 32.633 minutes. Now, I said it was to the west. Longitudes are often given in east or west longitudes, so this number here should always be positive. Whether it's positive or negative depends on whether it's specified as an east or west longitude. So, for example, east longitudes are positive from Greenwich into Europe. So if you're in Europe, you're going to have a positive east longitude, and you will set this to east and put your longitude in here. If you're in the Americas, you're going to have a negative east longitude or a west longitude. So you'll set your longitude to west, put a positive number in here. So for the Americas, you're going to have positive west longitudes. I've put a space here between the degrees and the minutes, but I could have used a colon. I could have put a second space and put in minutes, I mean seconds. Same thing with latitude here. We're going to go with 34 degrees. I'm going to put in a colon, 10.441 minutes. Now we're going to specify the elevation, which is 2020 meters. I could have clicked that first and changed it to feet, put in the number of feet instead. We're going to stick with meters. Okay, so we're done. We're going to click OK. Our location has been listed here, and let's check. Our longitude looks right, 106 degrees, 32 minutes, 38 seconds, and 34 degrees north, the right elevation. Our time zone, we're in the United States. The time zone is Mountain Standard Time. I say Mountain Standard Time, that's what it is in the winter. We do have daylight time, daylight saving time, so I'm going to select daylight saving rules and choose US and Canada. That will automatically apply the daylight saving rules for the US and Canada. Notice there are other options here, the EU and Australia. Next, we're going to set up the sky brightness. That's very important to our model, so we should take a little care to get that right. I'm going to click on it here. I wouldn't use the basic tab for imaging. Let's go with the advanced tab. There's several ways to set up your sky brightness. If you have a meter and you've measured the value, you can, if it's magnitudes per arc second squared or magnitudes per arc minute squared. We're going to go with magnitudes per arc second squared. If you know the Bortle scale, you can put that number in here. But for most people, there's going to be a valid number here, and this comes from our light pollution database. It's pretty accurate, so I'm going to just click Use, and we're going to go with that number. The next thing to do is to set the weather. Now, there's a couple things here for the weather. The first is what the current conditions, and that's just a default value for a typical night. And you can set that to anything you want it to be. But it gets more interesting if you click the button here. There are monthly current conditions, or monthly typical conditions, I mean. So we can put in a value for January for this location. In the middle of the night, it's typically about 40 degrees in January, and the humidity is about 20%. So I've typed in those values. We go to February, 45 degrees, again, 20%. We would click all the way through all of these selections. Now, why is that important? It's important because we're usually planning ahead. Sometimes we're planning for the summer when it's in the winter. We have no idea what the weather's going to be like that night. If we put in the typical conditions, SkyTools is going to use those typical conditions when it does the calculations. Last thing to set is the seeing. What kind of seeing do we typically have year-round at that location? And I'm going to set it to good seeing, about full width half max of 1.25. Click OK. The last thing to set up is the obstructed horizon. I'm going to click Create. There's a lot of ways to do this. We can do it from a chart. We can take readings from the telescope. I'm going to read them in from a file. And here's the file. It's very simple. This is the longitude, the azimuth, which is 0 degrees, and the altitude of the obstructed horizon is 25 degrees. I have another entry which is 360 degrees, and again 25 degrees. So this file here could have any number of azimuth altitude pairs. In this case, I'm just doing something really simple. I'm saying it's going to be 25-degree horizon all the way around. I'm going to go ahead. Here's that file here. I'm going to go ahead and read that in. And we're done. We have created our Mesa Redonda Observatory.